Welcome my dear students in secondary 1. Today we'll start our first lesson in trigonometry. Our lesson today is about directed angle. We studied before in preparatory year 1 what do we mean by angle, and we said that the angle is the union of two rays with a common starting point. Like here, for example, I have the ray BA and the ray BC have the same starting point. The union of the two rays is an angle. We can read this angle ABC or angle CBA, or we can read it as angle B, the name of the vertex. And we can notice that the vertex name is in the middle when we read the angle. The two sides of this angle are the two rays BA and BC. This is an angle. Today we will study a directed angle. The directed angle, it means an angle with a direction. We can't read it in any way. You should start from the initial side to the terminal side. So now we have the two sides of the angle. One of them is the initial side and the other is the terminal side. In this example, for example, here I have this angle. The initial side here is OA. This is a ray, and the terminal side is OB. I can write it as an ordered pair starting from the initial side to the terminal side. So I write the ray OA, then the ray OB in the ordered pair. If I want to read this angle, I should start from the initial side. So I write AOB. This angle is AOB. Here I have the opposite. The initial side here is OB and the terminal side is OA. So I write the ordered pair as OB, then I write OA. So this is the initial side and this is the terminal side. So this angle is BOA. And of course, angle AOB doesn't equal the directed angle BOA, because the ordered pair OA, OB, the ray OA, OB doesn't equal the ray OB, OA. Okay, so here in the directed angle, the direction is very important. Here, for example, I have an arrow. The arrow in the first angle is from the side ED, ray AD, to the side EF. So this is the initial side and this is the terminal side. The second angle, the arrow is from OX, then OY. So this is the initial side and this is the terminal side. Okay, this ordered pair represents a directed angle. I'll start from the initial side. So I write DEF. Start from the initial side, DEF. And here, what is the ordered pair here? The initial side at first, so OX, then OY. OX, then OY. So the angle is XOY. Start from the initial side, then the terminal side. So we have two directions of any angle, a positive direction or a negative direction. So any directed angle can be positive or negative. Positive if the direction of rotation from initial to terminal side is anti-clockwise, like here. From OA to OB, the initial side is OA and the terminal side is OB. This direction is anti-clockwise. So this is a positive direction of this angle. The negative direction, if the direction of rotation from the initial side to the terminal side is clockwise. So this is a negative angle. So I have positive or negative angle. Okay, so each non-zero directed angle has two values, a positive and a negative. Two measures, positive and negative, such that if we add the absolute value of the positive and negative, positive and negative measure, it will be 360. Okay, if you add the absolute value of the positive and negative measure of any angle, any directed angle, it will be 360. So if we want to get the positive measure of any negative angle, I'll add 360. If I have the negative measure and this is if I want to get the positive, I'll add 360. If the angle is negative and I want the positive, I'll add 360. If this angle is positive and I want the negative measure, I'll add negative 360. For example, I want to get the positive measure of the directed angle whose measure is negative 170. This is a negative measure, so I'll add 360 to get the positive measure. So the positive measure is 190. Number 2, I want the negative measure of the directed angle whose measure is 320. So I'll add negative 360. It will be negative 40. Okay. Here I want to find the measure of the directed angle theta in each of the following. Okay, number 1. Here I have theta is positive and this angle is a negative angle 64. So I'll add 360 to negative 64. So I'll get 296. Here, for example, I want the negative or positive. I want the negative measure because the arrow is, the direction from rotation from initial to terminal is clockwise. So I want the negative. So I'll add negative 360. I'll get negative 225. The third one, I have 90 degrees 33 minutes and I want the positive measure. This is the negative measure, so I'll add 360. So the result will be 269 degrees and 27 minutes. Okay, we have another concept which is the standard position of the directed angle. Okay, what do we mean by a standard position of the directed angle? We have two conditions. If the two conditions satisfied, then this angle is in the standard position. Number 1, the initial side lies on the positive direction of x-axis, like this. OA, for example, lies on the positive direction of x-axis here and here and here. The initial side is the positive direction of x-axis. Condition number 2, its vertex is the origin point of the orthogonal coordinates plane. So here the vertex is 0 and 0. Here the vertex is 0 and 0. Here also this is the origin. So the origin point 0 and 0 is the vertex of this angle. So if you have an angle and this angle in a standard position, it means that the vertex is the origin and the initial side is the positive, lies on the positive direction of x-axis. What about the equivalent angles? If we have any angle theta, this angle is a directed angle in the standard position, then if I want to get equivalent angle to this angle, I can make one turn, two turns, or three, or whatever. So theta, if I add or subtract any integer number, positive integer number multiplied by 360, I'll get an equivalent angle to this angle. Okay, so all the equivalent angles have a common terminal side, so they called equivalent angle. The equivalent angle has the same or a common terminal side. Okay, so any equivalent angles have a common terminal side. So generally, several directed angles in the standard position are said to be equivalent if they have one common terminal side. Let's take this exercise. Determine two angles, one with positive measure and the other with negative measure having common terminal side. I have 100 degree and I have negative 250. 100 degree, I want one positive and one negative, so I can add 360, then I'll get the positive, and I can add negative 360 to get the negative. Okay, so if you add 360, it will be 460. So 460 is a positive angle equivalent to 100 degrees. By the same way, 100 degrees minus 360 equals negative 260. So negative 260 is a negative directed angle equivalent to 100 degree. What about negative 250? By the same way, I can add 360, it will be 110, or subtract 360 or add negative 360 to get negative 610. Another exercise, determine the smallest positive measure of each of the angles whose measure are negative 62 degrees, negative 225, 405, and negative 115. Here, for example, negative 62. I want the smallest positive measure, so I'll add 360. If you add 360, it will be 298. This is the smallest positive measure for negative 62. Negative 225, I can add 360 also to get 135. Okay, what about negative 115? By the same way, add 360. Okay, negative 405 at first, 405, negative 405, and I'll subtract 360 because this angle is greater than 360 to get 45 degrees. So I can add or subtract 360 as I want. The last one, negative 115, add 360 to get 245. Determine the negative measure of each of the following. 72. How can I get the negative measure? As we said before, I'll add negative 360. So I'll get 288. But I want the negative measure, so I should subtract again. Okay. Here negative, I have here a negative sign, negative 288. Okay, so here I'll add a negative sign, negative 288. Okay, for 1150, by the same way, I'll subtract 360 4 times to get negative 290. So this is the negative measure for those angles. We studied before that the plane is, or the orthogonal plane, divides into 4 quadrants. The first quadrant, the second, and the third, and the fourth. Okay. Here, for example, if I want to determine in which quadrant is the angle, I mean the terminal side of this angle. So I mean the terminal side. Okay. Because I'll deal with the angles with in a standard position. So the terminal side always is the positive direction of x-axis. So I need the terminal side. If I want to know the location of the angle in which quadrant, I mean the terminal side of this angle. Okay. So I'll determine in which quadrant is the angle. But at first I want to put it in the standard position, the positive measure. Okay, if you have an angle, write the smallest positive measure. It's easier to get the quadrant in which this angle lies. Okay, this is the first quadrant, the second, third, and fourth quadrant. The first quadrant from 0 degree to 90, the second from 90 to 180, the third from 180 to 270, and the fourth quadrant is from 270 to 360. Okay. If the terminal side lies on the two axes, in this case, the angle called quadrantal angle. It means if the terminal side, for example, on the positive direction of y-axis or negative direction of y-axis or negative direction of x-axis, then this angle is called a quadrantal angle or any equivalent angle to this angle. Okay, let's start here. For example, angle 0, 90, 180, 270, 360, all are quadrantal angles. Let's take this exercise. Determine the quadrant in which each of the following directed angle lies. Let's start with the first one. I want you to notice that if you want to determine the quadrant, we have to find the smallest positive measure of the angle. It's to be easy to get the quadrant. Number 1, for example, 67. 67 is between 0 and 90. So 67 in the first quadrant, from 0 and 90 here in the first quadrant. Okay. Number 2, I have, for example, negative 220. What is the smallest positive? I'll add 360 to get 140. 140 greater than 90 and less than 180. So the second quadrant. 875. Okay, I want to get the smallest positive, so I'll subtract 360 2 times. I'll get 155. So this is in the second quadrant because it's between 90 and 180. What about negative 2020? Also, I'll add 365 times. This time it will be 140. So it's between 90 and 180. So also the second quadrant. Okay. So we studied how to determine the quadrant in which the terminal side of a directed angle lies. We studied how to get the smallest positive angle and how to get a negative or a positive measure of a directed angle. And also we studied the equivalent directed angles. That's all about our session today. Thank you very much for watching. Next session we will study this system of measuring angle. We will study degree and radian. Okay, thank you very much for watching. See you next session and goodbye.